So if you have ever wondered about reducing material usage on FDM prints, we are going to do exactly that right here. Generally, we want strong, sturdy parts, but minimizing material usage can be ideal for very early prototypes, checking dimensions, prints used to create molds, or any part that doesn't need a lot of mechanical strength and you plan to print hundreds or thousands of. Starting off with a simple cube, we get an estimated 6.54 grams used with default settings and a 0.4mm nozzle. The very first change we can make is reducing the amount of solid infills from the walls, bottom layers, and top layers. You have to put the minimum shell thickness to 0mm, otherwise it will continue to create multiple solid layers. If we go check what impact this had, we can see that we are now at 4.79 grams, which is a 27% decrease, but we can keep going. Heading over to Infill, we'll swap over to rectilinear and a 5% infill. We can also turn off the skirt. Checking again, we can see we're down to 3.24 grams now, which is a 50% decrease. Just examining that top bridging layer, it looks sufficient, and we may even be able to take that down here in a minute. Next, we're going to make this part even more fragile and lightweight by toning down the perimeter and infill extrusion width. For a 0.2mm layer height, I try to keep the width no lower than 0.35mm. A 0.15mm height could go a bit lower down to 0.32mm. I'll go back again real quick and remove the solid bridging layer that I mentioned. Now we're down to 2.53 grams, which is a 61% decrease from default. You can also see that decreasing the infill extrusion width decreased the gaps within the infill, making bridging easier, but the gaps are still large enough that the filament could droop in between. We will fix this by using a semi-dense infill layer instead of a solid bridging layer. Just set a height range modifier to include that specific layer and manually set a higher infill percentage. Quality results may vary from the bridging layer optimization, but it does help us to get to our 60% reduction. I'll go back through one more time so you can see the settings that I changed. Moving on to a more practical example like the Benchy, we can continue to see these material savings pan out. With default settings, we get 12.15 grams, which includes tons of perimeters that can be toned down. So if we run through and apply all of our setting changes used in the cube example, we see that we're now down to 4.61 grams, which is a 62% reduction. This is great, but we still need to make sure the print will be successful. As we make our way through the print, we can see that the perimeters are fine, but a problem with the bridging pops up with only using one top layer. The quick answer to this is going back and just adding the solid bridging layer back in. This appears to solve all of the bridging issues, but pushes us back up to 5.23 grams, which is 57% reduced. Like in the cube example, it is possible to use height range modifiers to manually set an infill percentage for the bridging layers if we wanted to reach our 60% again. This is a choice you will have to make for each part, and this is pretty much everything I wanted to touch on for this video. Thanks for watching, guys and gals. Solder, out.